So in this lesson here, we're going to look at the trig ratios of any angle. That can be exact trig ratios or approximate trig ratios. Let's start with finding trig ratios, exact values, given special angles in a triangle. So the steps I'm going to use, I'm going to sketch the angle and find the reference angle. Once I've done that, I'm going to create a right triangle by dropping a perpendicular line from the end of the angle to the positive or negative x-axis. Once I've done that, I'm going to label the sides of my triangle, paying attention to the signs in that quadrant. And then find the trig ratio of that triangle in that particular quadrant. Here's an example. Exact value of tan 150. First thing I want to mention is if it says exact value, that means no decimals. Just like on the last question, no decimals for an exact value. So first thing I'm going to do is sketch my angle 150 degrees, which is in quadrant number 2. So sketch my angle. And now find my reference angle. So 150 is less than 180. So the reference angle is 180 minus 150, which is 30 degrees. So instead of working with tan of 150, I'm going to work with tan of 30 degrees in quadrant number 2. So looking at my triangle here, in quadrant number 2, let's label the sides. So along here, x is negative, y is positive, hypotenuse is always positive, and I'm looking at my base angle of 30 degrees. So to figure out tan of 150, I can say that that would be opposite, positive 1, over adjacent, negative root 3. Or rationalizing my denominator, negative root 3 over 3. Now the nice thing is I can check to see if I'm correct or not by plugging it into my computer. So I can plug in tan of 150, and I can also plug in negative root 3 over 3. Seeing that both values match, I know I've done this correctly. Let's try another one. Exact value of cosine 315 degrees. So again, I will sketch my angle, which is a quadrant 4 angle. So 315 degrees right there. And I'll find my reference angle. So 315 is not as big as 360, which is my x-axis angle. So my reference angle is 360, take away 315, or 45 degrees. So instead of working with 315 degrees, I'm going to work with 45 degrees in quadrant 4. So there is 45 degrees in quadrant 4, and I'll label my sides with that quadrant. So the x value is positive, the y value is negative, and the hypotenuse is always positive. So cosine is adjacent over hypotenuse, 1 over root 2, or rationalizing my denominator, root 2 over 2. So to see if I've done that correctly, I can put it into my calculator. And you can see that cosine of 315 and root 2 over 2 have the same value, so I know I've done that correctly. So let's look at each of the triangles that I could have in all of the quadrants. So there's 4 different triangles that I could have in each of the quadrants. Notice the hypotenuse is positive in every single quadrant. So if I look at quadrant number 1, along the x it's positive, and along the y it's positive. So all my sides are positive, which makes all of my ratios positive as well. In quadrant number 2, along x that's negative, and along y that's positive. So anything involving the adjacent side will be negative, which would be cosine and tangent, making sine the only positive ratio. In quadrant number 3, x is negative and y is also negative. So the only thing that's positive is the hypotenuse. So sine and cosine are negative because the adjacent and the opposite are negative. However, tan is positive because that's the ratio of opposite over adjacent, and 2 negatives make a positive. Lastly, in quadrant number 4, x is positive and y is negative. So anything involving an opposite will be negative. So that means that sine and tangent are negative and cosine is positive. So this is the cast rule that's going to help us when we're doing exact or approximate values of any trig ratio. So the cast rule again tells us when something is positive in that quadrant. So C stands for cosine, only positive there. A stands for all, S stands for sine, and T stands for tangent. Remember that in every quadrant, the ratio is positive in 2 places and negative in 2 places. So each quadrant has 2 positive ratios and 2 negative ratios, with the exception of quadrant number 1. So looking at finding the exact value ratio, if you're given the exact value ratio, how do you find the angle? Well, if I'm giving you an exact value ratio, it means it's one of your special angles, 30, 60, 90, or 45, 45, 90. So you can use the special triangles or your hand trick. Once you've figured out what the reference angle is, use the sign of the ratio to place that reference angle in 2 quadrants. And then you can use the rules of finding angles with reference angles as shown below to find out what the angle is. And of course, always check on the calculator. So let's do an example with an exact value ratio. So exact value again means no decimal. So if I want to solve sine of theta equals -1 over root 2. The first thing I'm going to do is look at my negative sign. So my negative sign just tells me what quadrant I'm in. So sine is negative in quadrants number 3 and 4. Now I'll look at my number, which is 1 over root 2. So since I'm dealing with 1 over root 2, I know I'm in this triangle here. Now sine is opposite over hypotenuse. Opposite over hypotenuse. So that tells me that my reference angle is 45 degrees. So I'm going to take my reference angle of 45 degrees and I'm going to place it in quadrants 3 and 4 to figure out what my angle is. So taking 45-degree angle and placing it in quadrants 3 and 4. In quadrant number 3, I'm going to do 180 plus my reference angle. And in quadrant number 4, I'm going to do 360 minus my reference angle to get 315. So if I've solved this correctly, sine of 225 and sine of 315 will both be equal to -1 over root 2. So I can put that into my calculator and you can see that all 3 values are correct. So I know I did my answer correctly. Now let's look at how do we find an angle given an approximate value ratio. Approximate meaning it could be a decimal. So the steps are exactly the same. The only difference is finding the reference angle. So to find the reference angle, we're going to need to use our calculator using sine inverse, cos inverse, or tan inverse. And that's with the absolute value of the ratio. The sign of the ratio just correctly places it in 2 different quadrants. Once we found the reference angle and the quadrants, we can then again find the angle just like we did before. So just a word on your calculator when to use each button. You want to use sine, cosine, or tangent if you have the angle and want the ratio. You're going to use sine inverse, cos inverse, and tan inverse if you have the ratio and want the angle. So let's go ahead and try an example. I want to solve tan theta equals -0.8090. So first thing is, let's focus on what the reference angle is. So if I look at just this here and I do tan inverse of that number there without the sign, that's going to give me my reference angle. So I can plug it into my calculator to figure out what my reference angle would be. So ignoring the sign, tan inverse of that this is now my reference angle. So it's not one of my nice special triangles. So I know that my reference angle is 39 degrees. So what I want to do now is look at the sine. So the sine of tangent is negative. So I want to find out, where is tan negative? Well, tan is negative in two places. It's negative in quadrant number 2, and it's negative in quadrant number 4. So I can put that reference angle in those two quadrants to figure out what the angle is. So let's take that reference angle and put it into quadrants 2 and 4. So in quadrant number 2, I'm going to do 180 minus my reference angle. So 180 minus 39 degrees. And that will be 141 degrees. And then in quadrant number 3, I'm going to do 360 minus my reference angle. So that's going to be 321. And again, if I've done that correctly, I can put it into my calculator and see if tan of 141 and 321, are equal to each other, and approximately approximately negative 0.8090. So you can see that they are in fact equal to each other, so I know I've done it correctly, and it's approximately 8090, 0 point that negative. Again, it's not going to be exact because we rounded, but you can see it's close enough to know that I'm in the right area. So I hope this video on finding angles given exact and approximate ratios was useful, and I will see you for the next one where we'll look at quadrantal angles. You guys can go ahead and do your practice questions and then turn to your textbook as well.